It's time to say hello to standard form. In class, we did slope-intercept form a lot, and we did point-slope form a lot. And we didn't really talk about standard form much. But here's standard form, ax plus by equals c. Right, there's some rules of standard form. The a, the b, and the c are all supposed to be integers, with a being a positive number. It's not supposed to be a negative number. And if we were in class, I'd hold you to those standards. But apparently, Mr. Khan doesn't do that. So, on the work you're going to be given, you're not going to be necessarily expected to change a to a positive number or get rid of fractions throughout. So I know what you're thinking. Standard form, schmandard form. Who cares? Well, you better, because one, you're getting a grade on it, and two, it can make your life a little bit easier. When you're in standard form, it's really easy to find intercepts on the graph. What's an intercept? Well, I'm glad you asked. An intercept is a point on the graph where the line crosses one of the axes. A y-intercept would be where it crosses the y-axis, and an x-intercept would be where it crosses the x-axis. Now, I know in class I talked about this a lot when we were doing slope-intercept form. What is the x value for every y-intercept ever? It's the same answer, 0. You have not gone to the right or to the left at all to be on the y-axis, so it's going to be, say if we're here, we'll call this point B. You've gone 0 to the right or left, and you've gone up B. So that is your y-axis. That's an intercept at the point 0B. So now we have to worry about the x-axis. This is new to us, but it's the same exact concept as the y-axis, just a little bit switched. So if I'm on my x-axis, I can go left or right, but I can't go up or down if I'm going to be on this axis point anymore. So let's take this point over here. We'll call it, negative a. Mr. Khan doesn't care about negatives anymore, so neither do I. So, if I'm over here, I moved over negative a, and have I gone up or down at all? Nope. So that would make this a 0. But no matter where I am on this line, my y value is always going to be 0. Just like no matter where I'm on this line, my x value is going to be a 0. Now that we know a little bit about the standard form being an easy way to find intercepts, let's actually practice doing it kind of more in an abstract sense. And then after that, we'll go into a little Khan example, and then you'll be set to go on your own. So, I told you standard form is ax plus by equals c. Now, if I want to use this to find the x-intercept, what is my y value for every x-intercept? 0. Because if I'm on the x-intercept, if I start at the origin, I can either go to the left and be on the x-axis, or I can go on the right and be on the x-axis, but I don't go up or down at all. So I'd have to have a 0. So, using that logic, if we plug in 0 for y, what's any number times 0? 0. So it just disappears. And we'd have ax equals c. If we divide both sides by a, we'll have our x-intercept equals whatever c divided by a is. Now, I know, that means nothing to you. We'll plug numbers in a second, but let's do the same thing with figuring out what our y-intercept would be. We know that our y-intercept has an x value of 0 always, and it could be anywhere up or down the y-axis. We start at our origin, we can't go left or right, or else we wouldn't be on the y-axis anymore, but we can go either up in the positive direction or down the negative direction. So, if we have our standard form equation, and we want to figure out what the y-axis is, and we know x is always 0, we can plug in 0 for x. And what's a number times 0? Any number times 0? 0, same thing. So now we can solve for y by dividing both sides by b, and we'd have y equals c divided by b, and whatever that answer is would be where we'd end up on our y-intercept. Again, abstract, but don't worry, in about 2 seconds, our first example, actually the only example for this video. Negative 9x plus 6y equals 18. Now I told you before that standard forms are a really great way to find intercepts quickly, so let's start by finding the x-intercept first. What is the y value for every x-intercept ever? If you're on the x-axis, you haven't gone up or down at all, so you have a y value of 0. So let's rewrite this, but plug in 0 for y. Now, why is that helpful? What's any number times 0? Exactly that, 0. So this disappears. We have negative 9x equals 18. All right, we've done one-step equations forever. What did we do? Negative 9 times x equals 18. We do the inverse operation. What's the inverse of multiplying? Dividing. So divide both sides by negative 9, and that will get x by itself. 18 divided by negative 9 is negative 2. All right, we've got 1 point, the x-intercept. Now we got to find the y-intercept. So let's use the same logic except in reverse. All right, what is the x value for every y-intercept ever? Yep, 0. So we're going to do the same thing. Instead of writing negative 9x, we're going to write negative 9 times 0, which is going to allow us to solve for y and then find our y-intercept. So negative 9 times 0 plus 6y equals 18. Negative 9 times 0, any number times 0 is 0, crosses out. Now we have 6y equals 18. What do? Inverse operation again. It says 6 times y. To reverse that, to get rid of it, we got to divide both sides by 6. And we get y equals 18 divided by 6 equals 3. Y equals 3. All right, well, we've done the hard part. We found our x-intercept and our y-intercept. Now it's for the payoff, where we plot both points, connect the dots, create a line, and then submit and get it correct. So let's first do our x-intercept. We found out that x equals negative 2, which means our point will be at the point negative 2, 0. So starting at our origin, we're going to go over 2 to the left. We're not going to go up or down. We're just going to put our point right there. All right. Now we're going to plot our y-intercept, which is at y equals 3. So we're not going left or right at all, but we're going to go up 3. 1, 2, 3. Plot our point there. And then connect the 2, draw the line through it, and we're done. And this is the graph of negative 9x plus 6y equals 18.